The image that we are analyzing is of an astronaut in space. In this image, the Earth is being illuminated by the sun, and the Earth is reflecting the light into space and onto the astronaut and the satellite. The reflection of the satellite illuminates the visor of the astronaut's helmet, creating an image or reflection.
Once generated, light is emitted from a source typically in all directions. The energy in a light beam travels in a straight line at a fixed speed so long as it is in a vacuum, as in space. When traveling through most gases, such as those found in our air, light propagates in the same way as in a vacuum, in a straight line at the speed of light. When it encounters some forms of matter, light can be reflected, absorbed, or scattered. Most objects reflect light from their surface in all directions, no matter what direction the light originates from. However, some of the objects, like polished glass or the calm surface of water, have special reflective properties that allow an image to form. In most cases, only part of the light is reflected, while some are absorbed by the object.
So the astronaut is in space, which is a dark area, thus light must be reflecting someplace. The description says the light is coming from the top of the image, which is also coming from the light reflecting of the Earth from the sun. Scientifically, this makes sense because as long as there is a luminous object hitting an illuminous object, light can be generated and reflected. Light is not only reflecting off the astronaut himself, light is reflecting off the satellite into the visor of the helmet. Without reflection off the satellite, we would not have the image of the satellite in the visor, and with the positioning of the light source behind the astronaut, only the half of him facing the Earth would be visible, not the half in the photograph. The satellite's reflection illuminates the front of the astronaut. All of this light, created by the sun, reflected off the Earth, astronaut, satellite, and the astronaut's visor, also needs to reflect towards the camera so the photo can be taken.
Do you want me to do this entire part? Looking at the astronaut's visor, a similar phenomenon can be seen in real life when you're looking at a pair of sunglasses. While some light gets through, some light is absorbed, and some light is reflected. The astronaut's visor is similar to sunglasses. He can see. Some of the light is absorbed, and as we can see in the picture, some light is reflected. This kind of example can also be seen when looking at ponds or standing bodies of water that do not have waves storing the reflection. Without the waves, the reflection is crystal clear. Another way to relate the picture to real life is the use of luminous objects and reflection. Just as in the photo, without a source of light, there will be no image or reflection. In a dark room with an apple and a lamp, if the lamp is not on and creating light, the apple will not be seen. If the lamp is on, the light is going from the luminous object, reflecting off the objects present, and the light that reflects off the object is reflected back to the eye so it can be seen. Just as in space, there needs to be the initial luminous object and the reflection so the objects can be perceived.